Welcome to The Explainer. Today, we're diving into a massive journey tracing the true origins of our modern information infrastructure. We're looking at how we went from painstakingly scraping symbols onto really fragile materials to, instantly beaming petabytes of data across the globe. It's an absolutely phenomenal story of human ingenuity, and honestly, it didn't start where you probably think it did.
Okay, let's dive into this. When you hear information age, your mind probably jumps straight to computers, the internet, maybe the glowing tech hubs of Silicon Valley, right? You might picture the mid-20th century, the invention of the microchip, or the launch of the World Wide Web. But actually, our modern digital existence is just the tail end of a much, much longer story. The real information age kicked off long before the very first circuit board was ever soldered.
Tracing this massive technological snowball effect takes us across nearly 2 millennia of innovation. We're going to start way back in 105 CE, hit a major milestone in 868, cross a huge threshold in 1455, and then see exactly how that literal explosion of data fueled the scientific revolution in the 1500s and 1600s. Basically, each of these historic innovations stacked perfectly on top of the last to build the world we live in right now. So, let's start with Section 1, the Eastern Roots, establishing the base hardware. To really understand the information era, we actually have to shift our focus away from Europe entirely. We need to look at this incredible slow burn of innovation that happened over in East Asia. Because before information could move quickly, humanity needed the right physical medium, basically what we'd call the base hardware. So around 105 CE, an official in the Eastern Han Dynasty named Kai Lun completely revolutionized communication. He developed a way to make practical paper by macerating plant fibers, specifically mulberry bark and hemp, into a pulped slurry. I know, turning tree bark and old hemp into mush doesn't sound super glamorous, but that slurry literally changed the world.
To really put this into perspective, imagine trying to run a massive, complex, imperial bureaucracy with the legacy tech of the time. It was incredibly limiting. Bamboo slips were super heavy and cumbersome. Imagine having to haul a whole wagon full of bamboo just to transport a few accounting ledgers. No way, right? And silk, while great to write on, was just prohibitively expensive. Then comes Kai Lun's massive upgrade, pulped paper. It was cheap, highly durable, and wonderfully lightweight. Just a massive foundational upgrade to human communication.
Fast forward to the Tang Dynasty, and bam, we hit another huge breakthrough. This new material, paper, merged with an incredible technique, block printing. Craftsmen carved entire pages of text or images in reverse relief right into wooden blocks. And this wasn't just art, folks. It was a highly sophisticated milestone in material science. It required a deep empirical understanding of ink transfer and wood durability. The result? The Diamond Sutra, published in 868 CE. It's the oldest known dated printed book. And this technology slowly began migrating along global trade routes, setting the stage for a massive societal shift.
Moving right along to Section 2, Gutenberg's precision engineering, or the hardware synthesis.
So, the crucial point is, Johannes Gutenberg did not actually invent printing. It's a super common misconception. What Gutenberg really did in mid-15th century Germany was recognize a massive data bottleneck. Hand-copying manuscripts was just way too slow for a world with growing universities and expanding trade routes. Gutenberg essentially acted as a brilliant systems engineer. He synthesized 3 interlinked technologies into one highly scalable industrial system: movable metal type, a new oil-based ink that would actually stick to the metal, and an adapted wooden screw press that was originally used for making wine. Now, what's really interesting about this slide is that the secret sauce behind that first step was actually precision material science. Gutenberg had to develop a highly specific durable metal alloy. We're talking a perfectly balanced mixture of lead, tin, and antimony. This exact recipe allowed the molten metal to be cast into thousands of perfectly identical letters that would cool quickly without warping or getting super brittle under the immense pressure of the printing press. Pretty clever, right?
And the whole shebang culminated right here, 1455. That's the approximate year the famous Gutenberg Bible was completed. And guys, this is an absolute threshold moment for humanity. It definitively proved that high-quality, complex knowledge could be mass-produced with absolute consistency. The elite restricted control over information, it was shattered forever.
Which brings us to Section 3, breaking the monopoly, going viral.
Almost overnight, printing presses spread like wildfire across cities like Venice, Paris, and London. information finally broke free and literally went viral. Let's use some modern tech analogies to really grasp this shift. Hand-copied manuscripts were basically full of glitches. Every single time a monk copied a book, human error naturally introduced mistakes. Plus, these books were super rare, heavily guarded possessions. Printed books, on the other hand, brought reliable bug fixes. Once a page was typeset, it had absolute textual integrity. It could be reliably replicated thousands of times over, turning knowledge from a guarded secret into a reproducible, accessible commodity.
And the early printers didn't just stop there. They started rolling out what we today would call UX updates, user experience upgrades. Down in Venice, Aldus Manutius realized books didn't need to be these massive, heavy objects chained to a reading desk. He created small, portable books you could actually carry around with you in your pocket. A real game changer. Meanwhile, in England, William Caxton started printing not just in academic Latin, but in the vernacular, the everyday language of regular people. These brilliant UX updates made scholarship accessible to a rapidly rising middle class.
Moving to Section 4, the engine of discovery, the first peer review network. So this newly democratized information network laid the direct groundwork for empirical science. It essentially became the ultimate engine for the scientific revolution. A perfect example of this is 1543. Nicholas Copernicus leveraged the printing press to distribute his heliocentric model of the universe, the radical idea that the Earth actually revolves around the sun. And this wasn't just some abstract philosophical argument. It was a mathematically complex framework that prioritized hard computation over inherited traditional dogma.
Printing fundamentally changed how science was done. Think about it. Because books were now identical and reliable, astronomers in Italy could look at the exact same data tables as astronomers up in Poland. It completely enabled continent-wide data comparison. It also allowed for the institutionalization of scientific journals and reinforced really strict standards for replication. So, in a very real way, the printing press effectively invented our modern scientific peer review process. How cool is that?
This beautiful scientific feedback loop reached an absolute climax in 1687 when Isaac Newton published his Principia Mathematica. Thanks to the incredible flow of printed data that came before him, Newton was able to synthesize the universal laws of motion and gravitation. This singular publication provided the theoretical foundation for the engineering innovations that would very soon trigger the Industrial Revolution. Theory and practical application were now fully locked into an amazing cycle of rapid acceleration.
Finally, we arrive at Section 5, Legacy of the Modular Mind, from metal to bits.
And this brilliantly illustrates exactly how that 15th century information explosion links directly to our modern digital existence today. It all comes down to modular design. Basically, modular design is the concept of taking a finite set of elements and recombining them into limitless arrangements to encode vast amounts of information. Gutenberg's reusable metal letters were really the first systematic application of this in infotech. Obviously, today we don't use metal letters, we use digital ones and zeros, bits. But the underlying concept? Recombining small, basic modules to build incredibly complex data, it's exactly the same thing.
This brings us to that incredibly famous quote from Isaac Newton. "If I have seen further, it is by standing on the shoulders of giants." The printing press literally expanded collective human memory. It meant that a scholar didn't have to just start from scratch in every single generation. They could actually read the verified printed work of their predecessors, stand on their shoulders, and reach even higher. It perfectly bridged the gap between early paper and the hyper-connected digital age we live in right now.
So, we've seen how Gutenberg's metal modular design eventually evolved into the digital bits that run our smartphones, the internet, and the AI models of today. That single threshold moment fundamentally changed the course of human history. So looking at the massive, unprecedented digital information explosion we are all living through at this very second, you gotta ask yourself, how will our current infrastructure shape humanity's next giant leap over the next 500 years? Really something to chew on. Thanks for joining this explainer, and remember to always keep questioning the everyday tech around you.